This video section will cover Section 26, Inspection of a New Aircraft, and it will also include a comprehensive preparation for first engine start, initial startup procedures, rotor system testing and tracking procedures. In Section 26, you will notice the pre-flight checklist consisting of several pages. This checklist is required to meet the FARs and keep the aircraft airworthiness certificate valid. Check each item on the checklist and enter notations where required. It is important that the builder thoroughly read each section in its entirety, including the diagnostic procedures of the RI-162F engine manual. This will help provide an overview and an insight leading to a successful and long-lasting power plant operation. The RI-162F power plant is designed to burn premium, unleaded, or leaded automotive gasoline, which has a minimum octane rating of 92. Use only gasoline from known major brand stations, which has fuel specially formulated for fuel injection, such as Mobil, Texaco, Arco, etc. 100 low-lead aviation gasoline may also be used. If you haven't done so already, put the battery in service by adding the electrolyte as recommended by the manufacturer. Always use safety glasses when handling the electrolyte. Charge the battery as per the manufacturer's instructions, and use an aircraft hydrometer to measure the specific gravity of each cell. Be sure and record the date the battery is put in service, and it is also a good practice to label the battery with that date. Do not connect the battery. Put gasoline in the fuel tanks or turn on the fuel pumps until advised to do so during these procedures. Inspect all of the installed fuel hoses and fittings, and make certain you have complied with the following rules. Make sure that there is an adequate clearance between the hose ends and anything they might be able to contact. While the hose end is flexible, the ends are not. Do not allow a hose to contact a sharp corner, nut, bolt, rivet, stem, or anything else that might cause damage. Do not allow a hose to rub against anything, even if the surface on which it rubs is flat. The stainless steel braid is a very efficient low-speed file and will abrade through anything that it moves against. In order to prevent chafing and to keep your hoses where you want them, support the hoses with wire ties or cushion loop clamps. Do not force the hoses to bend too tight. Do not kink the hose, either by bending too tight, by misalignment between the hose end and fittings on the short assemblies, or by getting the whole assembly into a helix on long assemblies. Check the tightness of all fuel hoses. Do not over-tighten the hose ends onto the adapter fittings. The seal is achieved by the design of the mating surfaces, not by muscle. If it leaks, it has probably been assembled incorrectly. Damage to the cone and seat can be caused by various mistakes on assembly, the most common of which are dirt and over-tightening. The Rotorway FADEX system is a totally unique and customized system designed especially for use in the exec 162F helicopter. It is extremely important for each builder pilot to completely understand the operation of the FADEX system and the following procedures. This knowledge is essential for you to properly construct, maintain, and fly the helicopter. Note, Rotorway has produced two versions of the FADEX system. There are slight differences in component location and arming and turning on procedures. Refer to the flight manual that was included with your helicopter. This video will be testing and demonstrating the earlier version. At the starter, disconnect the wire between the starter and the starter relay. Ensure that this wire cannot short against anything when the battery is eventually connected. This is done to protect against inadvertent start of the power plant and to allow later testing of the starter relay. Inspect the routing, security, and condition of the FADEX wiring harness. It must be well supported and not allowed to chafe against any other component. Wires should not be pulled tight or radically bent. Connector plugs should be secured and not allowed to vibrate excessively. All plugs should be checked for proper connection with locking tabs engaged. Caution: installation of the 36-pin plug onto the ECU with the white pin alignment piece removed will damage the pins of the connector plug. This could result in an erratic and dangerous malfunction of the ECU. Before connecting the battery, first make sure all of the overhead switches are off. It is also a good practice to verify that there is not a short in the system before connecting the battery. This can be accomplished by using an ohm meter between the positive and negative battery cables. Connect the battery. During the following initial testing, if any of the switches fail to function properly, use the appropriate wiring harness schematic to troubleshoot the problem. Warning: do not attempt to disassemble any FADEC connector plug without first contacting Rotorway's customer service. Special tools and procedures must be used on these parts to prevent damage and possible component failure. Test the fuel pumps for proper operation by turning the switches on and off one at a time. You should be able to hear a pump when it is operating. Only run the pumps for a short time, since running a pump dry can cause damage. Each switch should operate one and only one pump. By feeling the body of a pump, you can tell if it is running or not. Test the fuel pump inertia switches on both the inertia switches from the mounting bracket. Hold one switch upright in one hand and strike it sharply with the other hand. Turn on the corresponding fuel pump switch. The pump should remain off. Reset the inertia switch by pressing downwards on the top of the switch. This should cause the fuel pump to turn on. Turn the fuel pump off and test the other switch in the same way, and reinstall the switches to the bracket. Test the ignition switches. Begin by disconnecting plugs indexed A and C on the FADEC wiring harness. These plugs attach to the 6-pin receptacles of the ignition modules. Turn the switches on and off, one at a time. Verify the voltage to pin A of the connectors as shown. Do not reconnect plugs A and C at this time. Arm the FADEC system. Refer to your exec 162f flight manual and follow the detailed procedures. Turn each FADEC switch on and off, one at a time, to ensure that each provides an independent source of power. The green light on the instrument panel should remain on during this procedure. If any problems are encountered, refer to the diagnostics section under ARM FADEC. Check the FADEC backup system. Refer to your exec 162f flight manual and follow the detailed procedures. You should be able to hear the secondary injectors. They should make a buzzing sound in all throttle positions except full open. Touch the body of each injector to ensure that both are operating. The green light on the instrument panel should be off and the red indicator light should be on. Check the switches in the following combinations as shown. FADEC 1 on, FADEC 2 and secondary off. FADEC 2 on, FADEC 1 and secondary off. FADEC secondary on, FADEC 1 and 2 off. Turn all switches off. Extended running of dry injectors can damage them. If any problems are encountered, refer to the diagnostics section under Secondary Backup System. Caution: if the fuel pumps are turned on when the secondary system is activated, fuel will be delivered to the engine even when the engine is not running. In order to perform the following procedures, it will be necessary to remove all wires connected to the ignition modules and carefully support the seat back panel as shown. Leave the ECU connected. Make sure that the wires are not pulled tight and the panel is supported. Rearm the FADEC system. The digital display monitor should be illuminated. If the digital display does not function properly, refer to the diagnostics section under Digital Display. When scanning the values of the monitor, the upper readout should be 0 engine RPM. The value for the engine manifold pressure and the barometric will be identical. In this application, their values are derived from the same type sensor. The throttle position should vary from 0 to 100 as the throttle position is changed. Since the engine is not running and is developing a vacuum, the manifold pressure value should be close to the barometric pressure value. These values are derived from two different sensors, which can vary up to 0.5 kilopascals in accuracy. As the throttle position is changed, the pulse width value should vary from 10.0 to 0.5. The value for the spark advance should vary from 14.0 to 12.0. The air and water temperatures should be accurate. If any values are incorrect, refer to the Diagnostics section under Sensors. Move the digital display to Diagnostics. The upper and lower readout should be 0. If an error code is displayed, refer to the Diagnostics section under Error Codes. Carefully disconnect the water temperature sensor plug. The yellow light on the instrument panel should activate. Number 5 should appear in the lower readout. Pressing the Set button should not clear the error. Carefully reconnect the plug. The error should remain illuminated, indicating the system's ability to detect a momentary error. Pressing the Set button should clear the error message. Warning: if an error is recognized by the FADEC during operation of the helicopter, do not attempt to clear the error message by using the Set button. This is to be done after landing to determine the nature of the problem. The only exception to this rule is normal diagnostic reset, which is performed during the startup procedures. Follow the same procedures as in the water temperature sensor test to test the primary throttle position sensor air temperature, and barometric sensors. The FADEC will switch control to the backup system if both the primary throttle position sensor and the manifold pressure sensor fail. A momentary error condition on either sensor will lock the error as it relates to this switching function. This means that the FADEC will switch to the backup system the instant the other load sensor fails, even if the momentary error has been repaired and cleared. Only a restart of the ECU will clear this lock. Restart the main ECU by turning off both FADEC switches and then rearming the system. Carefully unplug the manifold pressure sensor. The yellow warning light on the instrument panel should illuminate. Number 2 should appear in the lower readout of the digital display. Carefully unplug the primary throttle position sensor. The green and yellow should go out. The secondary system should activate and turn on the red light. Turn off both FADEC switches. Carefully reconnect the throttle position sensor and the manifold pressure sensor plugs. Rearm the FADEC system. The red and yellow light should be off and the green light on. Turn off both FADEC switches. Carefully disconnect the ECU plugs and carefully lay down the seat back panel. Do not engage the starter at this time. To test the operation of the starter relay, connect the voltmeter between the frame ground and the previously disconnected relay wire. Turn the key on and the instrument switch. Engage the starter button. The meter should read 12 volts. Turn off the key and verify lockout of the starter circuit. Turn off all switches. Reconnect the starter relay wire to the starter. Do not crank the engine at this time. In Section 18, you are instructed to install the components of the oil system and prime the engine oil pump. Review this section and the engine manual for further information. Check the oil filler cap dipstick to verify your engine has the proper level of oil. During the start procedure of the helicopter, one of the first things the pilot must do is verify the oil pressure is rising within 5 seconds after the engine starts. The small tube that runs from the oil filter fitting to the pressure gauge on the instrument must be purged of all the air bubbles to get an accurate reading. Disconnect the fitting on the gauge and place the end over a container. Disconnect the other end of the tube at the oil filter. Use an oil can filled with engine oil to pump oil into the tube. Keep pumping until the tube is completely filled with oil. Then reconnect the fittings. Review Section 20 of the construction manual and video to review the installation of your fuel system. Do not perform the following test until a helicopter is ready for its first startup and idle check. Have a fire extinguisher by the helicopter and wear eye protection. If you have a leak, the pressure of this system can cause fuel to be sprayed surprisingly far and fast. Remove any panels that will give you better view. Put a total of 3 to 4 gallons of fuel in the tanks. This is adequate for testing and for initial start of the helicopter. Turn on the fuel valve. Turn on the instrument switch. Turn on one fuel pump and check for leaks. Immediately turn off the fuel pump and fuel valve if a leak is detected. If a leak is found, pressure will remain in the system after the pumps and valve have been turned off. Slowly disconnect the hose at the spot of the leak and be prepared for fuel to spray from the connection. Turn on the second pump. Carefully check for leaks. One good way to check for small leaks is to run a clean finger on all the connections on the fuel system. Even a small drop can be found using this procedure. If a fluid shows up on your finger, smelling it should verify if it is fuel or simply oil used during the installation process. The importance of this inspection cannot be stressed enough because a fuel leak on this system can be extremely dangerous. Even the smallest leak can develop into a large one in a system operating at high pressure. The design of this fuel system consistently pumps fuel in a circle when the pumps are running. In other words, gasoline is being returned to the fuel tank continuously. The sounds which the fuel pumps make will change as the air is removed from the system. If you turn off the fuel valve and the pumps are running, you will hear the sound change. This sound change is the result of the restriction on the inlet of the pumps. Do not operate the pumps with the fuel valve off. The fuel pressure gauge should be reading 55 psi. Production differences between gauges, pressure senders, and pressure regulators can cause a variance in the indicated pressure up to 5 psi. There should be a difference of 1 to 3 psi between the operation of 1 and 2 pumps. After all the initial leak testing is complete, turn off all switches and pull the fuel valve to the off position. You must continue regular inspections of the fuel system for leakage. This is especially important during the first few hours of operation and during each pre-flight inspection. Carefully connect the ECU and the ignition modules. Install the seatback panel and check the security of the wiring. Arm the FADEX system to test for proper reconnection of the components. Turn off all switches and verify that the fuel valve is off. Before starting the helicopter engine for the first time, be sure you have reviewed and performed all procedures relating to preparation of the cooling, oil, and ignition sections in the RI-162F engine manual. It is important that you read the entire engine manual as vital procedures are contained throughout. Each section contains relevant information essential to properly start and operate the power plant. Warning: failure to follow all these procedures may damage the engine. Monitor the RI-162F engine very closely, especially during the first 5 hours of operation. Warning: it is very important to not exceed an idle until the coolant and oil temperatures reach 160 degrees Fahrenheit and the thermostat opens. Oil temperature must also be in the green range on the gauge. If the thermostat is closed and the engine exceeds 3,000 RPM, the pressure in the cooling system could more than double and cause considerable damage. Do not idle the engine for long, extended periods of time. Once the coolant and oil temperature reach the green range on the gauges, the RPM and load should be varied for the most effective run-in. The engine should never be idled for longer than is necessary. On shutdown, idle the engine only long enough to cool down and stabilize the engine components. A water temperature drop of 5 to 10 degrees Fahrenheit after set down from a hover is adequate for component stabilization. Follow the maintenance requirements closely. Frequent inspections will expose the need for adjustments before problems and damage occur. Individual experiences may also direct you toward additional inspections and adjustments beyond the increments outlined in the engine manual. Warning: do not operate the RI-162F power plant in any rough running condition under load. High-frequency vibration or roughness in the engine is readily felt through the pedals in the ship. The initial startup procedure on the engine will require at least 2 people. Each person should have definite responsibilities. A comprehensive review of all procedures and related duties ahead of time will eliminate most of the confusion during the exciting first few minutes of engine operation. As an option, the builder pilot may start the engine the first time without the main rotors installed. Warning: do not exceed idle RPM when starting or operating the engine without the main rotors, even after the engine reaches operating temperature. The tail rotor drive system must be connected and properly tensioned to perform the idle check. The purpose of the idle check is to verify the oil system is operating properly and remove the air from the coolant system without the added dangers of the moving rotors overhead. Propylene glycol is a recommended choice for the coolant antifreeze. Propylene glycol offers improved cavitation corrosion protection and better overall performance than ethylene glycol. It is also necessary to include a compatible supplemental coolant additive, a rust inhibitor water pump lubricant. Reference the engine manual for more information. Rotorway International has tested and recommends a product called Complete, which contains the proper concentrations of propylene glycol and a corrosion inhibitor additive. The best type is the pre-mixed version, which already includes the proper amount of distilled water added. This product is distributed by Fleetguard Incorporated, a Cummins diesel company. Caution: never use water only in the cooling system. Never mix tap water or well water with the antifreeze concentrate. Use only distilled water to mix with the antifreeze solution. Review the prints, construction manual, and video to ensure that all cooling system components are attached and routed correctly. Verify that all hoses are secure and that hose clamps are installed past the bead or flare on the end of the joining tube or fitting. All hoses must be protected from the exhaust manifold heat source. The tie down and routing of all hoses must be done in such a way as to prevent chafing damage. Water pump priming and air removal is one aspect of the initial engine startup which requires two people. One person, the pilot, must start the engine and monitor all instruments. The other person is needed to bleed air from the system and to check the cooling system for leaks. This person will also be in an excellent position to watch for several other systems for potential problems. Caution: water temperature must be monitored constantly during the entire initial startup procedure. It is an inherent characteristic of the cooling system to repeatedly lose the prime at the water pump during this period, causing the water temperature to increase very rapidly. Complete the following before startup. Open all three air bleed valves slightly. The valves are located on the rear corner of the radiator, the water pump, and the elbow on the top of the water jacket, all on the passenger side of the helicopter. Note: install a length of clear plastic hose and clamps on the air bleed valves and use a catch container under all bleed areas to recover as much coolant mixture as possible. Slowly pour the coolant mixture into the surge tank until it flows continuously from the three bleed valves. Once a steady stream of coolant without air bubbles is emitted, close the valves. Leave the surge tank cap off at this time. The surge tank must be continuously filled during the idle check. Turn on the instruments and verify that the needle on the water temperature gauge, as well as on the oil temperature gauge, moves from a low temperature setting to a pegged low position. Ensure that enough additional coolant solution has been prepared so that the surge tank can be kept full after the engine is started. Note: the 162F's coolant capacity is 2.8 U.S. gallons. Note before proceeding, all other systems must be prepared before starting the engine. Before starting the engine, perform this modified startup checklist. Note: this modified checklist is for the idle check only.
Go through the startup. Make sure the fuel is pumped out.
Oil the chain and check the master link. Check that the clutch is disengaged. Turn on the key and the instrument switch. Arm the FADEC system. This will vary from the two ECUs that have been produced for the exec162f. Refer to the flight manual you received from Rotorway. Turn on the fuel valve. Turn on one fuel pump and verify fuel pressure. Turn on both ignition switches. Place the controls in the start position. Set the throttle to 0%. Make sure the other person or persons are clear of the moving parts and tail rotor. The pilot can now start the engine. Oil pressure should rise within 3 to 5 seconds. Engage the clutch. The pilot must monitor the oil pressure, water temperature, and oil temperature. Keep the throttle at 0%. The pilot should check the operation of both ignition systems, both fuel pumps, and both FADEC switches. Then leave all switches on. Turn on the alternator. At the first sign of rapid water temperature increase, open the air bleed valve in the water pump and bleed the system until no air bubbles appear in the coolant. Proper priming of the water pump is evident by warming of the hoses to the water pump as well as a slow increase in water temperature. Caution, do not allow the water temperature to exceed 185 degrees Fahrenheit during the initial startup period. If a rapid and continuous increase in water temperature occurs and cannot be stopped by bleeding at the water pump, the engine must be stopped before the water temperature reaches 185 degrees Fahrenheit. Allow the engine to cool, then bleed out the air at the 3 air bleed valve locations. The thermostat will begin to cycle open and close when the water temperature reaches approximately 160 degrees Fahrenheit. When this cycling starts, additional air will flow through the system, most of which can be bled out through the radiator valve. The other person must keep the surge tank 1/2 to 3/4 full at all times. After you have determined the system is free of air bubbles, make sure that the surge tank is 1/2 to 3/4 full and install the pressure cap. After approximately 7 minutes of running, the oil temperature should reach 140 degrees Fahrenheit. Stop the engine by shutting off both fuel pumps. When the engine stops, turn off the fuel valve. Turn off all switches. Disengage the clutch. Check the belt tension on the tail rotor belts and adjust as necessary. Let the engine cool and remove the cap from the surge tank. Caution, the system must be allowed to cool before removing the cap. Removal of the pressure cap when the cooling system is hot can result in severe burns. Open the air bleed valves in the water pump and radiator and allow coolant to bleed for 10 to 15 seconds while keeping the surge tank full. Close the valves, fill the surge tank 1/2 to 3/4 full, and replace the cap. A warm engine restart will display an initial temperature increase, followed by a rapid decrease if correct priming is accomplished. Rebleed the system after each of the first few runs to ensure the complete removal of air. Continue to monitor the water temperature, especially close during the first few hours of operation when problems are most likely to occur. Install the main rotor blades, refer to section 24. The center of gravity requirement for any helicopter is very important to its safe operation. In order to determine that your Rotorway exec 162f has been built correctly and the weight and balance is correct, you will have to perform a static hang test. Refer to the flight manual for proper setup and procedures. Select a test area that allows control of observers in the event that if anything flies off, it will not cause damage or injury. Only essential personnel should be around the helicopter when the engine is running. Brief all personnel that will be approaching the helicopter in operation to always approach from the front quadrant in view of the pilot, and be sure that the pilot is aware of your approach before getting close to the boundary agreed upon. Be aware of the tail rotor dangers when moving around the helicopter for inspections and other tasks. Set the helicopter in an area that the main shaft can be straight up in all directions if possible. This will help when verifying measurements. The helicopter must be tied to the ground for the first run-ups. Reference the construction manual section 26 for the correct tie-down procedures. Oil the chain and check the master link. Start the engine as per normal startup procedures and allow the engine to idle until the temperature is in the green. The control positions must be the same location on the following checks, because if the control position moves, the results will change even with the same settings on everything else. Track with the tracking stick as shown here. With the engine running at idle RPM, track with the tracking stick and adjust the control rods until both blades have a mark. Adjust the control rod on the blade without a mark by making an index mark on the rod and turning the rod to move down for correct tracking. Move the control rod a quarter of a turn at a time. Restart the engine and allow the temperatures to move into the green. Then check for the smoothness of the rotor by increasing the engine RPM. Normally 300 rotor RPM will be the roughest if the rotor system is out of balance. If the system is out of balance, adding a number 8 screw 3/4 inches long with a 3/16 inch regular washer to the end of one blade will take care of the problem, provided, of course, if weight is the problem. And you may need to remove the screw from that end and add it to the other end to get the weight on the correct blade. The handheld digital photo tack is used for calibrating the dual rotor engine tack on the instrument panel. This must be done the first time the engine is operated above a fast idle. To use the photo tack, hold it upwards toward the rotor blades while they are turning. The tack works by counting each time the light source is interrupted. Very bright light, reflections might make it difficult to get a steady reading. If this happens, try holding the tack in a different location or point it towards the ground at the shadow of the blade. With the engine at operating temperatures, open the throttle to bring rotor RPM to 520. The instrument rotor tack must read 100%. The needle of the engine tack must be in the middle of the green and aligned with the rotor's tack needle. If necessary, adjust the needles by turning the appropriate screws on the back of the gauge. Screw A is for adjusting the engine RPM, and screw B is for adjusting the rotor RPM. If any adjustments are made, recheck the readings after a few run-ups to verify that the gauges stay calibrated. Note when verifying tachometer readings with a photo tack, the collective handle must be below normal hover position to prevent the chance that the main drive belts are slipping. If the engine RPM needle, after calibration, rises above the green arc when the aircraft is in the light position or hovering, it is an indication that the belts are slipping. The engine should not be operated in this condition, as damage could occur to the drive belts and pulleys. Perform a tracking procedure at operating RPM with the tracking stick. If adjustment is needed, adjustments to the reflex trailing edge will be necessary. Refer to the instructions that came with your reflex edge fixture. Many things related to the rotor system and blades can affect the smoothness of the aircraft. It is sometimes difficult for new builder pilots to recognize the symptoms correctly. Understanding the feedback through the controls will help the pilot diagnose and correct the problem. Some of the more common problems are the following. The lateral half of the rotor disc is unbalanced, therefore you get a lateral oscillation or lateral shake. The usual symptom is a lateral shake of the cyclic, and after making adjustments, it either remains the same or gets worse, but you never get rid of it. Probable causes are the rotor hub is not shimmed correctly on the shaft, retention straps are not installed on the blades correctly, the static lead lag was adjusted without the rotor blades being free enough to pivot correctly. Other problems that will not allow you to obtain a smooth rotor system are, if the weight of each blade does not equal the other, the result is that the heavier blade is trying to pull the helicopter off-center. Probable cause is there was a large amount of weight difference added to the one blade when doing the static balance. Now when they are turning, the requirement is different. If the pitch horns were not installed correctly, this would cause the tracking to change when the collective is changed or when the blade flaps to correct for dissymmetry of lift. The probable cause is the hub, swash plate, and both blades were not level when finding the location of the pitch horns on the retention straps. If the tracking is not staying when in forward flight, or the cyclic has a tendency to want to find its own center, the probable causes are the rotor hub is shimmed too tight. The swash plate scissor, which is the scissor between the counterweight and the rotating swash plate, is too tight. This prevents the blade from flapping freely, resulting in making the system rough. The cyclic control is hard to hold in position, and the cyclic handle wants to follow the rotation of the rotor blades. The probable causes are the slider ball adjustment is too tight, or the airfoils of the rotor blade do not match. The collective control will not stay in position. It moves up and down when your hand is removed. The probable cause is the cord balance is off. However, you can adjust it with a reflex edge. Bend the reflex edge the way you want the control to go. Bending up makes the control go up, and bending down on the edge makes the control go down. Refer to the reflex edge instruction for which panels to bend to correct collective stick pressures. In conclusion, if the builder pilot takes the time to follow the proper rigging procedures and maintains close tolerances in setting up the main rotor system, he or she can expect to have a smooth running rotor system with normal component life.